Hello everyone. Today we will be discussing another new problem. This is a very interesting problem of projectile motion. So you have an inclined plane and this inclined plane is inclined at an angle theta with the horizontal. There is a box. This box is dragged upward on the inclined plane with an acceleration g sine theta. If there is a particle present inside the box and the particle is projected at an angle 90 degree with respect to box with some velocity u, if it is found that the maximum height reached by the particle, this maximum height that the particle reaches is perpendicular to the inclined plane, is equal to range of the particle is parallel to the inclined plane, then find the value of cot theta. Once again I will tell you the problem. We have an inclined plane. Inclined plane is inclined at an angle theta with the horizontal. There is a box. The box is pulled upward with acceleration g sine theta. A particle is projected vertically upward inside the box. This particle is making an angle of 90 degree with the vertical. Now if the maximum height reached by the particle, which is perpendicular to the inclined plane, and the horizontal range covered by the particle parallel to the inclined plane are equal in their values, then you need to find the value of cot theta. So first thing that I want to tell you that what are the data given over here. U is given. U is, what is U? Let's see. Velocity of particle with respect to the box. This is u and it is in vertical direction, so I am calling it j cap. How will I call it j cap? Suppose I am considering this is y axis and this is x axis. Whenever you solve this sort of numerical problems where there is projectile motion on an inclined plane, please consider this approach. This coordinate system is very helpful. Consider y axis perpendicular to inclined plane and x axis parallel to the inclined plane. So in that regard, I can say that velocity of particle with respect to box is in this direction. So u j cap. Now at any instant of time, at an arbitrary instant of time t, what is the velocity of the box? Velocity of box with respect to inclined plane, the box was initially at rest, so it is dragged. So it is 0 plus g sine theta into t, and what is the direction? The direction is along x axis, so I cap. So velocity of box with respect to inclined plane is equals to g sine theta into t I cap. So this is my equation A and this is equation B, suppose. So when I got these two ideas, I can find out what is the velocity of particle with respect to inclined plane. Therefore velocity of particle with respect to inclined plane is velocity of particle with respect to box plus velocity of box with respect to inclined plane. This is a simple concept of relative motion, relative velocity. I think you know. So from here what we can write? Velocity of particle with respect to inclined plane is particle with respect to box. So u j cap plus g sine theta into t I cap. So basically you have got this expression, which is a very important equation. So if there is an observer who is sitting on the inclined plane, for that observer velocity of the particle is this. The x component is g sine theta into t and y component is u. So therefore what we can say, velocity of particle with respect to inclined plane along x component is g sine theta into t, and velocity of particle with respect to inclined plane y component is equals to u. Once we got these results, now we can find out the different important deductions. Okay, from these results. Suppose I want to find out that what is the maximum height attained. Now in order to find out, let's find out the acceleration which is experienced. Please see this very carefully. For any particle, acceleration due to gravity, due to earth will act in vertically downward direction. So this is the direction of g. Because of this angle theta in this direction, what you will get? You will get g cos theta. So this angle is theta, so this is g cos theta. And in this direction, what you will get? You will get g sin theta. So basically, when this particle is going up, this g cos theta is trying to oppose its motion. It is the retarding, it is causing some retardation. Okay. So this g cos theta is acting along negative y-axis and it is basically trying to decrease this u. So if I want to find out the maximum height which is attained, we must understand why is the maximum height attained. So with respect to inclined plane, this particle is having a projectile motion which has both I component of velocity and j component of velocity. So the maximum height is attained because of the vertical component of velocity, right? And vertical component of acceleration or retardation, whatever. So if I want to find out what is the maximum height attained, how will I approach this particular problem? You please see that if you consider this particular path, if you consider the path of this projectile, so then what you can write? That Sy, suppose I am considering the vertical displacement of the particle. So this particular projectile with respect to inclined plane looks like this. So this sort of parabolic path it follows. So this is equals to velocity of particle with respect to incline y into time of flight minus half the retardation is g cos theta, so that's why minus g cos theta tf square. So what is the net vertical displacement? When the projectile starts its motion from here and reaches here, so along y direction, what is its net displacement? Net displacement is 0. So I can write 0 is equals to v pi y component is u. So u into tf minus half g cos theta tf square. So from here what will I get? I will get the total time of flight tf is equals to 2u divided by g cos theta. So this is my equation 2. So this is the time of flight of this particular projectile. Now if I want to find out the maximum height, how can I find out the maximum height? The maximum height which is attained by the projectile during its motion. I hope you have written down till here because very soon I will need to rub off these parts. So if you have not written down, please see to it and then I will proceed. So from here I found out what is the velocity of the projectile with respect to inclined plane and what is its total time of flight in this entire process. So now you see H max. What is H max? H max is definitely, you know, u square by 2g. So velocity of particle with respect to incline, its y component whole square divided by 2 times the value of retardation. So 2g cos theta. And what is the y component? It's u square. So it is u square by 2g cos theta. Okay. So this is my equation 3. So this is the H max, maximum height which is attained by this projectile. That is Vpi, velocity of particle with respect to inclined y component whole square by 2 times retardation. What is the retardation? G cos theta. It is trying to oppose the motion. You throw a ball vertically upward. What is the maximum height attained? The velocity with which you project the particle. Suppose that is u. So it will be u square by 2g. So here also same approach. So we got an expression for H max. Now we also got TF, the total time of flight of this projectile, to u by g cos theta. So how much horizontal range does this projectile cover in this time? In this time, how much horizontal range it covers? Horizontal range means along x direction how much distance it covers. So according to me, from here to here, this is the horizontal range. So R is equals to VPI x. Why horizontal range is covered? Because of the projectile's x component of velocity, horizontal range is covered. So VPI x multiplied by TF. And what VPI x we saw? That VPI x component is a function of t. So I want to find the maximum horizontal range. So T is equals to TF. This condition must be satisfied. So velocity of projectile with respect to inclined plane, its x component when t equals to TF into TF. So this is nothing but g sin theta into TF. So it is g sin theta into TF square. TF square is this. So 4u square by g square cos square theta. So 1g cancels. So you get 4u square by g sin theta by cos square theta. Okay. So in this way we have got equation 4. So now we have got horizontal range and we have also got H max. Once we have got it, so equation 3 and 4, using equation 3 and 4, we can equate these two. So according to the problem, these two values are equal. So according to the problem, H max equals to horizontal range. So u square by twice g cos theta equals to 4u square by g sin theta by cos square theta. You cancel one cos theta, cancel one g, u square cancelled. So therefore cos theta by sin theta you bring it to this side, so you get cot theta, and that is equals to 8. So what is the required value of cot theta? That you are asked to find out. That how much will be the value of cot theta? It is equals to 8. Okay. So this is your answer. This is how we solve this problem. Please see it properly. Okay. Now we have solved this problem. What I want you to understand in this particular problem, some key concepts. This problem is fine. It's a good problem, not a very tough problem though. But what are the key concepts that you should always remember when you are solving different projectile related problems associated with an accelerated frame or on an inclined plane? You see, so basically you projected the particle perpendicular to the inclined plane. When I draw this U, then please understand where am I sitting? I am sitting here. I am standing here. When I am inside the box, according to me, this is the velocity. Okay, so the observer is inside the box. That's why I wrote velocity of particle with respect to box is u j cap. I told you if this is the inclined plane, then you always consider this is an x-axis and this is your y-axis. It always helps. But the moment I don't sit inside the box, when I am inside the box means I along with the particle both are going upward with g sin theta. Now you think about an observer who is standing on the inclined plane. So for this observer, I am telling this observer is observer Q, this observer is observer P. So for observer P, velocity of particle with respect to box, the observer who is standing here, he is seeing that the box is going. Along with it, the particle is also moving. So for this observer, you will get velocity of particle with respect to inclined plane. Okay, and velocity of particle with respect to inclined plane is velocity of particle with respect to box plus velocity of box with respect to inclined plane. Now, what is the key concept in this particular area? You, by changing this frame of reference, have actually managed to find out the velocity of the particle with respect to inclined plane. And you got something like this, that velocity of particle with respect to inclined plane is equals to u j cap plus g sin theta into t for an instant of time t I cap. You got something like this. So you have expressed velocity of particle with respect to inclined plane, that means for this observer. Now you see, so what this observer sees, for this observer, this particle has a y component of velocity. So this is u j cap, suppose, and it also has an x component of velocity. So this is g sin theta into t I cap, suppose. So this is your x axis, this is y axis. So what will be the resultant direction? So the resultant direction will be something like this. Okay, parallelogram rule. So basically for this particle, for this person, the projectile is going in this path. It's following a parabolic path. Okay, and this is the horizontal range which we calculated, and this is the maximum height which we calculated. And it is told that these two are equal, h max and rx are equal. Now you please see, if this is your axis, the particle starts from here and ends here. That means on the same x level, on the same horizontal level, if I say this is horizontal, on the same level the particle is landing. That means the vertical displacement of the particle is zero. That is the concept used here. So whenever you have an obliquely fired projectile going from one level reaching back to the same level, okay, from here it started going back to the same level, then its net vertical displacement along y direction is zero. And you can use this concept in order to find out the time of flight. And horizontal range, you got this one. This is velocity of particle with respect to incline. This is the velocity of particle with respect to incline. So in this direction what you have? Velocity of particle with respect to incline y component. And in this direction velocity of particle with respect to incline x component. Now because of this velocity along this direction it is covering h max. And because of this velocity along this direction it is covering the horizontal range. So this is the physics behind it. By using this principle, Sy equals to 0, we found out the time of flight, and using that we could find out the horizontal range. And when we found out h max, just simply y component of velocity, then simply u square by 2g. Okay, this you don't forget. Students often write g. Don't forget that on an inclined plane, when you take the components of g, this is g cos theta is opposing this motion. So in this direction, g cos theta is opposing the motion, okay, and g sin theta is acting in this direction. So g cos theta is trying to oppose the motion of this flight. So these are some of the critical concepts that I wanted to discuss in this particular problem. It's a very interesting problem in my opinion. Thank you very much.